Okay, so today's video is about energy transformations. An energy transformation, or sometimes it's called energy conversion. These are the same things, they're just two different terms for the same idea. An energy transformation is a change from one form to another. So we have one form of energy, and then it changes to a different form. And we're going to go through all the forms here in a second. Any form of energy can be changed into any other form. So it doesn't matter what we start with or what we end with. They can change from one form to another. Okay, here are the first two forms of energy. Thermal energy is the total energy of the particles that make up an object. This is sometimes also called heat. So the faster the particles move, the more thermal energy it has. And we're actually going to do a completely separate video on thermal energy, so we will cover more about this in a future video. Chemical energy is the energy stored in a substance that can be released when the substance reacts. So objects have chemical energy stored in them, and when they undergo a chemical reaction, that energy is released. Remember with cough, sneezes, and burps, that the please excuse, cough, sneezes, and burps, the excuse stands for energy, and that is chemical energy. So an example of chemical energy is food. When we eat food, our stomach digests it, and that's a chemical reaction that releases energy. Fuel, like gasoline in a car, it sets on fire, and that's a chemical reaction that releases energy. And also batteries. They store different substances in the batteries, and when they react, energy is released. So chemical energy requires a chemical reaction to be released. Okay, next is electrical energy, and this is one that you're probably very familiar with. Electrical energy is the energy of moving electrons. Might be kind of confusing. Electrons are just part of an atom. So when these outer parts of the atom are moving around, then we get electrical energy. We get electrical energy from wall outlets in our houses and also through wires. So if you plug something into the wall or it uses wires of some sort, it's probably electrical energy. Sound energy is caused by an object's vibrations. So when you hit it or you strum it or something like that, the vibration causes air to move, and that creates sound energy. Some examples are a guitar. So when you strum a guitar, you're making those strings vibrate, and that causes the sound. Your voice releases sound energy. So your vocal cords vibrate as you breathe through them, and those vibrations produce the sound of your voice. Okay, and then the last two types. Light energy is caused by the vibration of electrically charged particles. So just like with electrical energy, those particles are moving, and thermal energy, those particles are moving. But if they have electricity or electrical charge to them, like electrons, then while they're moving, they produce light. And this one I understand is kind of confusing, but it's pretty easy to recognize. So like a lamp, the light that it gives off, a TV, headlights in the car, these all give off light energy. So this one's kind of tricky to understand how it works, but it's really easy to know when it's happening. And nuclear energy is energy that can be caused by changes in the nucleus of an atom. So remember in chemistry when we talked about that every matter is made of atoms, the center of that atom is called the nucleus. So the nucleus is the center of the atom. And when that changes, then it gives off nuclear energy. Two atoms can come together, the atom can be split apart, stuff like that, and then nuclear energy is given off. And this happens in the sun. That's how we get our energy from the sun. The light and heat is formed from nuclear energy. And then also nuclear power plants, like we talked about with our energy resources. Okay, so let's talk a little bit more about those forms of energy and how they transform. So in an energy transformation, the amount of energy going into an object must equal the amount of energy coming out of that object. So the amount in joules, the total number going in, must equal the total number coming out. And we're going to do an example. So the energy may have a different form, but the amount is the same. So going in and coming out, that energy may look completely different, but the total number is the same. And remember from our last video, this is the law of conservation of energy. So this applies to energy transformations as well. All right, so we are going to do an example. And, excuse my lack of artistic ability. Okay, so we are going to follow the energy that goes through this system. So here's the sun, and it is providing light and heat or thermal energy to the apple. So the sun gives its energy to the tree, to the apple. And let's say this is a total of my pen's not working very well. Say this is a total of 1,000 joules. Okay? So we have 1,000 joules of light and heat going into the apple. Then you come along and you eat the apple. Well, how much energy is the apple giving to you? It has to be 1,000 joules, because that's how much energy went into it. So the amount of energy going into the apple equals the amount of energy coming out of the apple. And what type of energy would this be? What type of energy is food? That would be chemical energy. Okay, so the apple is giving you 1,000 joules of chemical energy. Because when you eat that apple, it reacts with the stuff in your stomach and creates chemical energy. So then you take that energy, you now have 1,000 joules of chemical energy, and you go to choir class. And you are going to produce sound when you're singing, but also you're going to produce a little bit of thermal or heat. Okay, since we're mammals, we're warm-blooded, we keep the same body temperature. So we have to produce heat. So if we have 800 joules of sound that you are now producing, how much thermal energy must come out of you? We have 800 of sound. How much thermal energy has to come out? And that's going to be 200 joules. Because we have 1,000 joules of chemical energy go into your body, so 1,000 joules of energy need to come out of your body. And that is 800 joules of sound and 200 joules of thermal energy. So if we follow the energy flow, we started with light and heat, or light and thermal energy, which was a total of 1,000 joules. So the sun gave the apple 1,000 joules. Then the apple gave you 1,000 joules, just in a different form. And then you used that energy and you gave off 1,000 joules, equals 1,000 joules. So again, it took different forms, with light and thermal, with chemical, and then sound and thermal. So the forms were different, but the amount, 1,000, 1,000, 1,000, stayed the same. And that's due to the law of conservation of energy.